All right, 3.6 variation. All right, so we have joint variation, we have inverse variation, and we have direct variation. And so there's different formulas for each one of those, which you should have them in your notes. But I'm going to do a quick refresher of the formulas just so you have it. Direct variation is y equals kx to the n. Inverse variation is y equals k over x to the n. And joint variation is y equals k x to the n z to the m. So basically we're just taking the stuff that they give us in these little, they're like word problems, but they're like one sentence. They're not really a word problem. And we plug them into whatever it's asking for. So they just say to solve each problem. So 8 says, if y varies directly as x y, okay, anyways, the wording is weird, but y varies directly with x basically is what it means, and y is equal to 9 when x is equal to 30. Find y when x is equal to 40. So basically we're going to take that formula for direct variation because it says it varies directly, and we're going to plug in what we know. The nth power, we only use that if need be, like if it tells us it's raised to a certain power. So in this case, we're not going to have an n value. So we're just going to be plugging it in as y, which is, or well, here, I'll do it this way. Y equals kx is the formula that we're using. So I'm going to plug in these numbers to find k, then I'll use k to find y in the second part. So 9 is equal to k times 30. So using the initial information that they give, I'm going to solve for k. So k is equal to 9 over 30, which is going to reduce down to 3 over 10. So I'm going to use this value then to solve for y when x is 40. So basically, I'm repeating this process over again. So I'm going to have y is equal to k now, which is 3 over 10 times 40. So then the 10 and the 40, that reduces down. So I'm going to end up with 3 times 4. So y is equal to 12, which is what I was trying to solve for. So always make sure that in the end you have what it wanted you to find. A lot of people are tempted to stop when they found the k value, but you've got to keep going all the way until you find y or whatever the particular thing is that they're asking you to find. Let's see. 10. If m varies jointly as z and p, I don't really like that phrasing, it's like with, and m is equal to 10 when z is equal to 2 and p is equal to 7.5. Find m when Z is equal to 6 and P is equal to 9. So basically with this problem, instead of using X, they've used P. Everything else is like it would have been in the formula that I gave you. So sometimes they'll swap out letters for things. And M is going to be Y. So I'm going to just make a note of that above for you. So M would be what we would have had as Y in our formula. And then P is going to be X from our formula. Just for the purpose of going back and looking at it. So the formula that I had given you was Y is equal to K X to the N Z to the M. So they've like rewritten stuff. The powers are not going to be relevant for this problem. We don't need them, so I'm just going to get rid of them. Because again, it's not saying anything's being raised to a power. If it did, then we would be using it, but it doesn't have that. So in terms of the variables in the problem that they've given us, I'm going to swap this out. So Y is M for our given problem is equal to K, which is what we're going to have to find first, just like we did in the last one, times Z is 2. Or, well, actually, we'll go back and pull in numbers in a second. So times Z, I guess X was first. X is P, so we'll do P and then Z that way. So that way we keep it as similar as possible. So this is the modified formula based on the problem that we have here. Okay, the other problem in the book that's a joint variation problem has the normal letters that we used. So now I'm going to plug stuff in. So basically I have M is 10, Z is 2, P is 7.5, so I'm going to solve for K. So I've got 10 is equal to K times 7.5 times 2. So I'm going to take, 7.5 times 2 is 15. So 10 is equal to K times 15. I'm going to divide by 15, so 10 over 15, which is going to be 2 over 3 is equal to K. So I'm going to use this number then to plug into the formula. So I want to find M. So this is what my end goal is to find M. When Z is equal to 6 and P is equal to 9. So M equals K is 2/3 times P is 9 times Z is 6. 3 and 9 can reduce, so then I've got 2 times 3 times 6, so 6 times 6 is 36, so M is going to be equal to 36. Let's see. So we've done direct, we've done joint. Let's look at an inverse one. So 12, if, huh?
Are the inverse ones the easiest ones?
I think direct is the easiest one, personally, but if Y varies inversely as X, and Y is equal to 20 when X is equal to 1/4, find Y when X is equal to 15. So in this one, they gave us X and Y, and obviously we're going to have to find K, so it's the same formula that I wrote for you up top. So that was Y is equal to K over X. Again, still not raised to a power, so I'm just using that. So I'm going to plug in. So I've got 20 is equal to K divided by 1/4. So to solve for K, I'm going to flip this over up here. So I'm going to be multiplying times, oh wait, I lied. I'm going to flip it over here first to make it easier. So this is going to be the same thing as K divided by 1/4 is the same thing as 4 times K. Okay, because we keep change flip. So 20 is equal to K times 4. So then I will divide by 4 on that. So 5 is equal to K. So then I'm going to use that to find Y. So Y equals 5 divided by 15. So Y is equal to 1/3. So you might think inverse is easier. I think direct is easier because you're not necessarily dealing with fractions, whereas like with inverse, guaranteed to have a fraction, but I don't know. I think the hardest one is joint, probably just because there's a lot of moving pieces. And especially when they don't give you the same letters as the formula that is in the book. Like, they give you a formula in the book, and then they proceed to use different letters. And
How do you figure out what the right letters are? You did look at, like, the format of the...
So part of it is the way that it's written. So it'll say, like, if M varies jointly as, like, Z and P in that case, that tells you that M has to replace Y, because, like, for the generic formula, what you would see is that it'll say, like, Y varies jointly as, what letters was it? X and Z. And so technically, by the way that they wrote it, I should have it as M is equal to K times Z times P, but that's not going to change because I can interchange the variables to whichever order I want them to be in. But M has to be Y, because it says if Y or M varies jointly, and whatever it says varies jointly has to replace Y. The other stuff is just going to turn into your variables. What you'll see in the next problem that we're going to look at is that it's going to say something varies directly as the square of something. At that point, when you see that phrasing, like the square of, the cube of, or something, that's when those exponent powers from here come into play. But normally we don't have a lot of that. Like, I think maybe 2 of the problems in here have it being raised to a power. So it's not bad. Maybe a third one, but 2 that I see immediately. So this one is going to actually combine 2 things. So the first one was just direct, the second one was joint, and the third one we did was inverse. But this one is going to involve 2 different types of things here. So it says, suppose P varies directly as the square of Z. So I'm going to go ahead and underline that just so that I see that. So the square of Z is going to mean I'm going to be raising Z, whatever it is, to the second power. So I'm just going to go ahead and make a note of that while I'm writing it. And inversely as R. So P is going to vary directly as the square of Z, but also P varies inversely as R. Okay, is basically what that means. If P is equal to 32 over 5 when Z is equal to 4 and R is equal to 10. Find P when Z is equal to 3 and R is equal to 32. So this is going to be combining basically two formulas together. So we've got directly, we would have y is equal to kx to the n, okay, generically. Obviously these aren't the variables I'm using, so I'll write the ones with the variables that I'm given here in just a second. And then also I'm dealing with inversely, so that's going to be y is equal to k over x, I think was the variable that we used. Yeah. And I put the to the nth power on this one because I know that I'm dealing with a power based on what I went ahead and underlined up here. Okay. So now, because it says that p is varying directly with one thing, but it also says inversely with something else, I'm going to combine these two formulas together. Okay. I don't have k, so all I need to do is write k once. K is a constant. It's just going to be a random number that's given to you. So I'm basically going to take these formulas and smush them together. Okay, so before I swap out with the other variables, my modified formula then would be, for this problem, y equals k times x to the n divided by x. But I'm dealing with different variables, so I'm going to have to rewrite it. But assume that the x to the n and the x on the bottom are two different numbers right now. I'm just combining the formulas as how I gave them to you in the notes. So based on what I'm given, it says suppose p varies directly. So p is going to replace what variable? What'd you say? Y. Yep. So p is going to be y. So I'm going to swap out p for y. So I'm going to go ahead and swap it out in both of those. Now, varies directly as the square of z. So that means that z is replacing which variable? Or, well, I guess it's not a good question. Or what would I write? What would I write to finish out this formula, I guess is what I'll say. So ignore everything over here, aside from what's underlined up there, because you need that. How would I finish out this modification of this formula if I didn't have the inversely part? P equals k times what?
K times Z R.
Nope. Ignore the inversely part. So I had x to the n, so that means I'm going to have z to what based on this? What does squared mean? 2.
Okay.
So I'm going to have kz to the 2. So now, I'm doing it as if it's separate. So suppose p varies inversely as r. That means that I'm going to have y is equal to k divided by what? Huh?
Z. R.
R. So now when I smush them together, I'm not really looking at this. I'm smushing these two together now because I'm obviously dealing with different variables. So P is equal to, K only gets written once, again, just because it's a constant number. It doesn't matter. Times Z squared divided by R. So now I'm going to use the information that they gave up here. P is 32 over 5, Z is 4, R is 10 to solve for K. So I've got 32 over 5 is equal to K times 4 squared divided by 10. So I'm going to go ahead and multiply by 10 over here, and I'm going to square the 4 on this side. So that's going to be 10 times 32 over 5 is equal to 16 times k. This 10 and the 5 reduce. So over here I've got 64 equals 16k. Divide by 16, it's going to give me 4. Yeah. So 4 is equal to k. But like the other ones, I'm not done yet because I ultimately want to find p with this new z and r value. So I'm going to use this formula again, but with the other numbers. So p equals k, which is 4, times z is 3, and that's squared, divided by r, which is 32. So on top, I've got 3 squared is 9, times 4 is 36. So I've got 36 over 32 equals p, and then I just need to reduce it. So p is equal to, so you can take out a 4, so that's 9 over 8. And that would be the solution for that one. Alright, so that's all we're doing out of this section. There's more in this section, but that's the main thing that we're going to do. So you're going to do 7 through 13 odd. So I did the even ones for you. And then what we're going to do, because we're, 387, is because 3 of you won't be here tomorrow. And I'm not going to give you a quiz on Wednesday if you're not in class tomorrow. Is on Wednesday we'll go over the odd ones, okay? Because this is obviously, I don't think it's a hard concept, but it's very different in terms of having to plug stuff in and all of that. So we'll go over the answers for these just to make sure that you got the process down and answer any questions you have. And then whatever's left on Wednesday and Thursday, we'll do review, and we'll do a quiz on Friday on 3-4 to 3-6. And then I'll probably go ahead and give you your notes video as well for 4-1 so that you can get that done for Monday. So, cool. Any questions? All right. So you can work on this now.